Hello everyone, welcome to my channel. So in this video we will be covering the problems based on the joint distribution, and for this you must have thorough understanding of the basic concepts of the joint distribution. So for this I'll share the link in the description box. So first go and watch out that video, then you will be able to understand the problems based on this joint distribution more clearly. So now let's start with the problem. So this is problem 1. The discrete random variable x and y, they have the joint distribution fxy, it is equals to cxy. So here these random variables, that is x and y, both the random variables are discrete, and their joint distribution function, that is the probability mass function, this is equals to cxy. For x is equals to, that is x is taking values 1, 2, 3 and y is assuming values 1 and 2, and this is the function is 0 otherwise. So the first question is that find the value of the constant c. So in order to have a probability mass function, basically we have two conditions. So the first condition, that the probability, that is fxy, this must be greater than equals to 0 for all the possible values of x and y. And the second condition, that summation over x, since it is a case of a discrete, so we'll use summation. So summation over sum over all the values of x, sum over all the values of y, and this fxy, this is equals to 1. So first we'll plot the probability mass function, that is the joint probability mass function table. So for this, we know that x is taking values from here, x is taking values 1, 2, 3. So x is taking values 1, 2, 3 and y is taking values 1 and 2. So this is taking values 1 and 2. So when x is equals to 1 and y is equals to 1, what is f of xy? That is f at 1 comma 1. So simply plug in x is equals to 1 and y is equals to 1. So this is equals to c. When x is equals to, that is for this point, when x is 1, this point is corresponding to f at 1 comma 2. So when x is 1 and y is equals to 2, this is equals to, so this is equals to, that is sub plug in x is equals to 1 and y is equals to 2. So this becomes 2. So this is 2c. When x is 2, y is 1. So x is 2, y is 1. So this becomes again 2c. Then x is 2, y is 2. So this becomes 4c. Then 3c and this is 6c. So the first condition, in order to find the value of C, these two conditions must satisfy to have a joint probability mass function, because it is a case of a two-dimensional random variable. So for the joint probability mass function, simply that all these probabilities must be greater than equals to 0, and second condition, that sum over all. So basically that is summation x is going from 1 to 3 and summation y is going from 1 to 2. F of x comma y, this must be equals to 1. So this is nothing but, when we plug in x is going from 1 to 3 and y is from 1 to 2, so this is, that is all these probabilities. F at 1 1, then we have f at 1 2, then f at 2 1 plus f at 2 comma 2 plus f at 3 comma 1 plus f at 3 comma 2. So this must be equals to 1. So substitute all the values of this probability. So this is equals to f at 1 comma 1, this is c, f at 1 comma 2, this is 2c. So simply substitute the values. So this is 2c plus 4c plus 3c plus 6c, this is equals to 1. So this is equals to 3 plus 2 5, 9 3 is 9 3 12, and this is 18c is equals to 1, and from here c is equals to 1 by 18. So to have a valid joint probability mass function, the value of c, this is equals to 1 by 18. Now coming to the second part, the second part says that calculate the marginal density of x and y. So for the two-dimensional discrete random variable, the marginal density of x, that is fx of x, this is given by summation over all values of y and f of x comma y. And what is fy at y? This is summation over all values of x. This is f of x comma y. So I am just plotting this probability mass function again. So for this we have x values and y values. So x is taking values, this is taking values 1, 2, 3, and y is taking values 1 and 2. So at x is equals to 1, y is equals to 1, this is c. So here I'm simply writing c. After that we'll substitute the value of c. Then we have 2c, this is 2c, this is 4c, 3c, 6c, and where c is nothing but 1 by 18. So for fx of x, simply take this fx of x here, and here we have fy at y. Now this becomes fx of x, that is, it is nothing but summation over all values of y, f of x comma y. So at x is equals to 1, take the summation over values of y. So when x is equals to 1, so take the summation over y values. This is equals to c plus 3, 2c, so this is 3c. Then this is 2c plus 4c, that is 6c. This is 3c plus 6c, this becomes 9c. And for fy at y, take the summation over x value. So this is c plus 2c plus 3c. This is equals to 6c. Then 2 plus 4 plus 6, that is 12c, where c is equals to 1 by 18. So what are the values of this fx of x and fy at y? So the marginal densities of x and y, when x is taking values 1, 2 and 3, then the corresponding marginal density at x is equals to 1, this is 3c. This is 6c, at x is equals to 2, it is 6c, and at x is equals to 3, this is 9c. And since c is equals to 1 by 18, substitute the value of c. So this becomes 3 by 18, this is 6 by 18, and this is 9 by 18. So this is equals to 1 by 6, this is 1 by 3, and this is 1 by 2. So the marginal density of x is taking values 1, 2, 3, and fx of x, this is equals to 1 by 6, 1 by 3, and 1 by 2. Similarly, we can find out the marginal density of y. So the marginal density of y is given by y is taking values 1 and 2. So simply write 1 and 2, and the corresponding marginal density at y is equals to 1. At y is equals to 1, this is 6c. So this is 6c. At y is equals to 2, this is 12c. Write it 12c. Substitute the value of c. So this is 6 by 18, and this is 12 by 18. So this is 1 by 3, and this is uh, I think 2 by 3. So this is equals to this. So that means the marginal density of y, this is 1, 2, and this is fy at y. It is 1 by 3 and 2 by 3. So in this way, we can find out this marginal densities of x and y. Now coming to the next part, that is, we need to compute the covariance between x and y. That is, this is the third part, covariance between x and y. So now in order to compute the covariance between x and y, we know that covariance, the computational formula for this is expected value of xy minus expected value of x into expected value of y. Now, in order to compute the expected, so one by one we will compute this expected. Here we have expected value of xy. So in order to compute the expected value of x, so the formula for this expected value of x, since it is x is discrete, so take summation, then summation over the possible values of x. So here x values is 1, 2, 3. So this is x is going from 1 to 3, and this x as it is, and the marginal density of x. So now here we have the values. That means from here we have the marginal density of x. So this is equals to, substitute x is equals to 1. When we substitute x is equals to 1, this is 1 multiply by fx at 1. Fx at 1, this is 1 by 6. So this is 1 by 6 plus, then substitute x is equals to 2. So this is 2 multiply by, this is 1 by 3. So this is 1 by 3 plus when x is equals to 3, so this is 3 multiplied by 1 by 2. So this is equals to 1 by 6 plus 2 by 3 plus 3 by 2. So this is, the LCM is 6 here. So this is 1 plus 4 plus 9. And this is 14 by 6, which is 7 by 3. So this is the expected value of x. Similarly, we can compute expected value of y. So for this expected value of y, we have this marginal density of y. So this is the marginal density of y. So in order to compute expected value of y, this is summation. Y is taking values 1 and 2 only. So this is 1 to 2, and this is y because the function is y. So y as it is multiplied by the marginal density of y. So this is equals to, when y is taking 1, so that means at y is equals to 1, substitute y is equals to 1 and fy at 1. Fy at 1 is 1 by 3. So this is 1 by 3 plus, when y is 2, this is 2, and fy at 2, this is 2 by 3. So expected value of y, this is 1 by 3 plus 4 by 3, which is equals to 5 by 3. Now, in order to compute the expected value of xy, so for this xy, what we can do, this is the joint probability mass function table. So this is the joint probability mass function table where c is equals to 1 by 18. So this becomes expected, or we can write simply as first we'll solve in terms of c, and at the end we'll substitute the value of c. So because c is equals to 1 by 18, so at the end we'll substitute. So now what is expected value of xy? Expected value of xy, it is summation over x values, that is x is taking values 1 to 3 and y is taking values 1 2, and this is, the function is xy, so this is right xy, and their joint probability mass function, because here we have two random variables, so their joint probability mass function. So simply one by one, first take x is equals to 1 and y is equals to 1, so that is at x is equals to 1, y is equals to 1, their joint probability mass function is c. So first multiply x with y and the corresponding joint probability mass function. So when x is 1, so 1 multiplied by 1, it is 1, and the corresponding joint probability mass function is c. So 1 multiplied by c plus, then x is equals to 1, y is equals to 2. So 1 multiplied by 2 is 2, and the corresponding joint probability mass function is 2c. Then similarly 2 multiplied by 1, this is 2 multiply, and the corresponding joint probability mass function is 2c. Then we have 2 multiplied by 2, it is 4, the corresponding joint probability mass function is 4c, plus 3 multiplied by 1, it is 3 multiplied by 3c, plus this is 6 multiplied by 6c. So the final is, this is c plus 4c plus 4c plus 16c plus 9c plus 36c. So when we add these, it is equals to 70c, and then substitute the value of c, which is 70 by 18. So now this is 9 and this is 35. So this becomes 35 by 9. It is the expected value of xy. So what is covariance of xy? This is equals to expected value of xy minus expected value of x into expected value of y. Now substitute the values of these. So this becomes expected value of xy is 35 by 9 minus 7 by 3 into 5 by 3. So which is equals to 35 by 9 minus 35 by 9, and this is equals to 0. Now the next question is, let x denotes the number of times a photocopy machine will malfunction, and y denote the number of times a technician is called. So x is assuming value 0, 1, 2, 3 and y is taking value 0, 1, 2. So x is taking value 0, 1, 2, 3 and y is taking value 0, 1, 2, and for this problem the joint probability mass function is given to us. So that means these are the corresponding probabilities corresponding to these x and y values. Okay, now The first part is find probability x is less than y. So these are nothing but the probabilities. So we just have to pick up the points where x is less than y. When x is 0, y is 0, both x and y are equal. When x is 0, y is 1. Here's x is less than y. So that means probability x is less than y. This is at the point f at 0 comma 1. That is x is 0, y is 1. The next is when x is 0, y is 2. That is f at 0 comma 2. And 1 comma 0, here x is greater than y. 1 comma 1, x is equals to y. 1 comma 2, x is less than y. So that is f at 1 comma 2. And then 2 comma 0, x is greater than y. 2 comma 1, x is greater than y, and 2 comma 2, x is equals to y. 3 comma 0, x is greater than y. 3 comma 1, x is greater than y, and 3 comma 2, x is greater than y. So we have only 3 points, 0 comma 1, 0 comma 2, 1 comma 2, where x is less than y. So simply sum up these three probabilities. The probability at 0 comma 1, so 0 comma 1, when x is 0, y is 1, it is 0.05. So this is 0.05 plus 0 comma 2, this is 0 comma 2, it is simply 0, plus 1 comma 2, this is 1 comma 2, it is again 0.05. Add these three probabilities and the final answer is 0.1. So this is the answer for this, that is 0.1. Next we have the marginal probability mass function of x and y. So for the marginal probability mass function, that is fx of x, this is summation over y values, that is f of x y's. And what is fy at y? This is the summation over x values, that is f of x comma y. So from this joint probability mass function table, this is fx of x corresponding to this x column, and this is fy at y corresponding to this y. So now at x is equals to 0, simply sum up these values. So fx at 0, this is equals to 0.2. fx at 1, when we add these values, so this is 0.2 and this is 0.5. Then we have 0.05, 0.1, this is 0.2 again. So this is 0.1. So simply add these values. Here row wise we have to add in order to compute fx of x. In order to compute fy of y, we have to add column wise. So the first one is 0.5. The second is 0. This is 0.15, that is 0.3, and this is 0.2. So these are the marginal densities of x and y. So when we write these marginal densities in the table form, so this becomes at x is going from 0, 1, 2, 3, taking values this, and fx of x, this is 0.2, 0.5, 0.2, and 0.1. So this is the marginal density of x, and y is taking value 0, 1, 2, and what is fy of y? So the corresponding y values is 0.5, 0.3, and 0.2. So 0.5, 0.3, and 0.2. So this is the marginal densities of x and y. Now the next is covariance between x and y. So in order to compute covariance of x, y, the computational formula is expected value of x, y minus expected value of x into expected value of y. So for this expected value of x, first we'll compute expected value of x. So expected value of x, this is the formula is, since x is discrete, so we'll use summation over x values. X is taking values 0, 1, 2, 3. So 0 to 3. The function is x, so x and the marginal density of x. So when we substitute x is equals to 0, so 0 multiplied by this, so this becomes 0, plus 1 multiplied by 0.5, so this is 0.5, plus 2 multiplied by 0.2, this is 0.4, plus 3 multiplied by 0.3, so this is 0.3. So the final answer is, this is 1.2. So this is expected value of x. Then expected value of y, this is summation y is taking value 0 to 2, and this function is y. So this is fy at y. So this is equals to 0 multiplied by 0.5, this is 0, plus 1 multiplied by 0.3, this is 0.3, plus 2 multiplied by 0.2, this is 0.4. So this is 0.7. Now coming to expected value of xy. So this is the given joint probability mass function table for this. So now expected value of xy, this is summation over x values. X is taking values 0 to 3. Summation over y values, which is taking values 0 to 2. The function is xy here. So this is xy and the corresponding joint probability mass function at x comma y. So that means first we have to multiply x with y and then take the corresponding joint probability mass function, multiply with this. So this is simply 0 multiplied by 0 and the corresponding joint probability mass function is 0.15. So this is simply first is 0 plus 0 multiplied by 1, the next is 0, 0 multiplied by 2 because 0 multiplied by 2 is again 0, so this is 0 again, plus 1 multiplied by 0, so this is 0, 1 multiplied by 1, so 1 multiplied by 1 is 1 and the corresponding joint probability mass function is 0.15. So this is 0.15 plus 1 multiplied by 2, this is 2 and the corresponding joint probability mass function is 0.05. Then plus 2 multiplied by 0, it is 0. Then 2 multiplied by 1, this is 2 and the corresponding joint probability mass function is 0.05. Plus 2 multiplied by 2, this is 4 and the corresponding joint probability mass function, that is 0.10. Then 3 multiplied by 0, so this is 0. 3 multiplied by 1, that is 3 and the corresponding joint probability mass function is 0.05, plus then 3 multiplied by 2, this is 6 and the corresponding joint probability mass function, that is 0.05. Now add these values, this is 0, 0, 0, 0. So all are 0, plus 1 multiplied by this, so this is 0.15. 2 multiplied by this, so this is 0.1. Then 2 multiplied by this is 0.1. Then 4, this is 0.4. Then here we have 0.15. Then this is 0.3. So expected value of xy, this is equals to 0. Then we have 2, 3, 4, 8, 9 and this is 12. So this is equals to 1.2. So this is the expected value of xy. So this is 30. Then we have 30 and this is again 0, then 1 2 3 4 5 6 7 8 and this is 12. So this is equals to 1.2 only. Now what is the covariance? Covariance, we know that expected value of xy is 1.2, expected value of y is 0.7 and expected value of xy is 1.2. So that means covariance, this is by computational formula expected value of xy minus expected value of x into expected value of y. So this is equals to, substitute the values, 1.2 minus 1.2 multiplied by 0.7. So this is 1.2, 1.2 minus and this is 0.84. So this is equals to, this is, we have 6 and this is 3, 0.36. This is the covariance between x and y. Hope you understood the concept of a joint probability mass function. So this is a question for practice. So please comment your answer for this question, and if you have any queries you can write your queries at my mail id. The mail id you can find it in the description box. I'll share my mail id over there. So thanks for watching. Hit like if you like this video and subscribe to my channel.